We'll have the discussion with some examples. The first task that we perform in supervised learning, and it is considered to be the most important task and has a number of applications, is classification. It is regarded as it is regarded as discrete in the sense that will be conveyed after discussing this example of digit recognition. In digit recognition, we have an input vector, and the input vector, the output of the learning algorithm, is one of the finite numbers of discrete categories. So we are given an input vector, and the output is a label from 0 to 9. So whether it is a digit 0 or 1 or 2, so the learning algorithm based on its processing, it gives you an output. In that sense, classification is regarded to be discrete. The second task that we perform in supervised learning is regression, and is considered continuous. We consider the example of prediction algorithms can be the parameters like reactant, temperature, and pressure, and the output is a real number which represents the yield of the process. In classification, we build these mathematical models, and the output predictions are some labels. The approach that we follow is that we have a set of input training vectors, we call it the training data, and these can be numerical values or they can be some categories. The output is always a category and it is a label. The way we can have success or failure, positive or negative, etc. We build a model based on the training data. It's a method in which the feature values are mapped to the labels, set of labels which are available to us. Another example that we can consider in this context is if the input feature values of the individual are is age, gender, income, and profession, we might like to predict whether this individual is a buyer or not. So the output labels or the output categorical variables are buyer and non-buyer, and the input categories or the values are the variables from age, variable like gender, which is categorical, income is a quantitative variable, takes real values, and then profession is also a categorical variable. The different applications of classification in medical diagnosis, we may have the input feature values. The sample vector will have the feature values with respect to age, gender, the history, the outcome of the test result, and the label output labels can be healthy or sick. Then in email spam detection, the feature values can be related to the sender's domain, the length of the message, the number of images, and different keywords, and the output can be spam or not spam. In credit card fraud detection example, we have the feature values can be the user, his location, the items he has bought or purchased, and the price. The output of the classification will be whether the individual this transaction is fraud or valid. There are different classification techniques that can be discussed, and they include the linear classification, which is which is based on logistic regression. We call it logistic regression, but we use it for linear classification. Then we have support vector machine, decision tree, naive Bayes, and random forest, neural networks, nearest neighborhood. You must have heard about these techniques, and we will discuss few of them in our subsequent lectures. The second type of task that we perform under supervised learning is regression. In supervised learning, we build models and we predict, and in this case, the predicted outcome is a real value. It's a numerical value as compared to in the case of classification, where the output were labels. The approach in this case is that the training set consists of numerical values. It can be features or the numerical values, and the output is always a real number. Mm. The model is a function which maps the predictor values, the input values, to numerical values. And an example can be that if we have the height of the mother, the height of the father, and the current age of the individual, we might like to predict what is the height of the individual. You can see that in this case, all the input values, they are real numbers or numeric in nature, and the output is also numeric. Different algorithms, regression algorithms that are well known among the community of machine learning is linear regression, logistic regression, polynomial regression, and so on. There are so many applications, including automobile design. We may use the test data to evaluate the engine performance and predict the performance of the engine if there is a change in the input data. In weather data analysis, we predict the temperature, pressure, other weather related quantities using the historic data. In astronomy, observational astronomy, the movement, position, and orbits of planetary bodies are predicted. Stock market, a very important application where we model our history or the learning we have from the past. We make a mathematical model, and then we will like to predict